Today we look at determinants. We're only going to look at finding determinants of square matrices. So, first, let's start off with a 2 by 2. He's a square matrix because we have an equal number of rows to columns. The number of rows is equal to columns. Okay, so this is how we do. I look at it like an X. I go this way, then I go this way. Okay, so 2 by 2, or 2 times 2 is 4. And then you subtract negative 3 times 1, which is negative 3. What does that equal? 7. This is your determinant.
Let's slow down for a second.
Now, for notation purposes, you might write something like this. The determinant of A can be written as 2, negative 3, 1, 2. And then you put straight bars. When you put straight bars like that, that means you're going to find the determinant of those numbers in there that make up the matrix. And then you take the 2 and you multiply it times the 2. You go across that way. Just same way you would make an X. And then you would go this way. Minus negative 3 times 1. And that's how I got my 7 right there. Okay. Now this one right here. This one's kind of scary. You guys ready for this? Determinant of B equals, okay, stay with me, 4.325. I'm just joking. It's just 5. Finding the determinants of a 2 by 2 and a 1 by 1 is not bad. Okay, but we're going to use 2 by 2 a lot, especially when we look at stuff like this dude. Okay, now this stuff is cool. I really enjoy this stuff, so check this out. In order to find the determinant of this, well, I'm going to take you guys to the finish line first. So this is what we're going to get to, all right? Now, you can choose any row. You can choose this row, you can choose this row, you can choose this row, or you can choose any column. This column, this column, or this column. You have to choose a row or a column to use, and it doesn't matter which one you choose. I know, this is crazy. It doesn't matter which one you choose, you'll get the same answer no matter what. So, might as well pick the one that will give you the less work. So, whichever one has the most zeros, that's the one you want to pick. Most zeros, smallest number. Now this one definitely, this one looks the easiest. Okay, but you can use whichever one you want. Any row, any column, okay? So let's write down the row. It's 0. And then what we're going to do is we're going to multiply it by the cofactor of row 1, column 1. Then we're going to add that to 2, from that 2 right there. And we're going to multiply that by the cofactor of row 1, column 2. And then we're going to add the last one, which is 1 times the cofactor of row 1, column 3. And this, my students, will equal your determinant.
What do you mean by the cofactors?
Okay, I know. Some of you guys are asking, what is the cofactor? I'm telling you guys, we're starting at the finish line, and then we're going to go back to the beginning, and I'm going to show you guys how we get to this point. Because once you know how to get to the cofactors, this is it. It's beautiful. Okay, now really quickly, I can say minor, row 1 or row I, column J, or I can say cofactor, row I, column J. Just so you guys know how to read this, that's the row, and the J is the column. Now, in order to find cofactors, we first must know how to find minors. Now, when I see minor, I think of minor determinants, like mini determinants, like little ones. I don't know if that'll help, but what we have to do is we have to find each minor. And the first minor we got to find is in row 1, column 1. Now, which number is in row 1 and column 1? There's only one number that's in row 1 and column 1. 0. 0 is in row 1, column 1. So we have to find the cofactor of 0. I'm sorry, the minor of 0. And then we'll find the cofactor after that. Let's just work on minors. So the minor of row 1, column 1 is going to equal the determinant of, check this out. What you do is you circle the number, and then it shoots out lasers. I'm not Like, I'm being silly, but that's what you do. Okay, and then you write -1, 2, 0, 1. You guys see how I got that?
No. Oh yeah.
You see them right here?
Yeah.
So lasers kill all the other ones, and those are the ones I wrote. Okay? All right, so, and remember what I told you guys, these straight lines, that means find the determinant. So you go -1 times 1, which is -1, and you're going to subtract 2 times 0, which 2 times 0 is 0. And so that equals -1. So the minor of row 1, column 1 is -1. Not bad, huh? Now, okay, so the next minor would be minor row 1, column 2. So it's a minor 12, it's row 1, column 2. This is going to equal, well, let's find our 2 by 2 here by circling it and shooting out our lasers. You guys ready? Okay. I know, you guys are all excited about shooting lasers here. So we get 3, 4, 2, 1 equals, you guys see how I got the 3, 4, and the 2, 1? There's a 3 there, 4, 2, 1. Okay. And then we go 3 times 1, which is 3, minus 8. That equals -5. Okay, let's do the other one. The minor of row 1, column 3. Now, why are we staying in row 1 the whole time? Well, because that's the one we chose. We chose row 1. And so now what we're going to do is we're going to circle that guy and have him shoot out his lasers. Oh, that's so great. I love that. All right, equals the determinant of our leftover numbers that did not die from the lasers. Equals. Then we have 0 minus -4 equals +4. Yeah, because 1 times +4 is -4. Okay, now it's +4. So now, these are our minors. Now, you can see we can actually find minors of every single one of these numbers. So we can find the minor for this one. Shoot out the lasers. Now we have those guys for our 2 by 2 matrix to find the determinant of. You guys, does that make sense?
Yes.
All right, it's just shooting out lasers. So if we wanted to find the minor of this one, we shoot out the lasers here, and then we have our matrix. You guys, does that make sense?
Is that only with 3 by 3s?
So now, how do we get cofactors? That's how you get minors. How do you get cofactors? Because cofactors are the things right here that we need. Now, I think you guys have a better understanding of what cofactor row 1, column 1 means. That means we're going to have to do something with this -1. Because that one is from row 1, column 1. Does that make sense to you guys? Yeah? Okay, so this is how you find cofactors. Now, in order to find cofactors, you need to know what a sign matrix looks like. I don't think it's called a sign matrix. I'm just kind of making that up. You always start with plus here, and then you go out and you alternate. So it's plus, negative, plus, and then it goes negative, plus, negative, and then it goes plus, negative, plus. This is the sign matrix for a 3 by 3. If I had a 2 by 2, which we're not going to use right now, but I want to show you, I'd start with plus right there, and it'd be minus, plus, no, sorry, it'd be plus, minus, and then coming out from the plus, it'd be minus, and then plus. Okay, so you see how it's always alternating? And I'm going to show you a different way of finding these without having to draw these. But first, let's find our cofactor for this one. Now, to find the cofactor, this is what you have to do. For the cofactor of row 1, column 1, we're going to take the minor of row 1, column 1, and we're going to multiply it by either -1 or +1. So how do I know if I multiply by -1 or +1? You look at this. What's that? +1, so it's a +1. So our cofactor for row 1, column 1 is just -1. Oh, because look, the minor is -1. So if I here, let me back up here. This 1 times -1, because that's our minor, that equals -1. So that's our cofactor.
The first one.
I got the first one because this determines the sign from this guy right here.
But why did you use
Well, this is the cofactor for row 1, column 1, right? Row 1, column 1 is a positive.
But where did you get the 1? The number.
Here, I chose 1 because you have to change the sign.
You
So
just picked one.
yeah,
Oh.
okay. And 1 doesn't change it.
Like, didn't you get that from the minor? Like the
So for this one, we're going to take the sign and multiply it times row 1, column 2 minor, the minor from row 1, column 2, that's going to be, what is, oh, that's -5. So what is this, though? What is the sign for row 1, column 2? Yes, that is negative. And so we're going to put a -1 right there. And that equals 5. So that's our cofactor for this guy right here. Now let's find a cofactor for the last one. It's row 1, column 3. That's our sign and our minor of row 1, column 3. So our sign times minor is 4. What's that going to equal? So what is the sign for row 1, column 3? +1. That equals 4. Okay, I'm going to pause 1 second. I'm not going to come up here yet. I first want to explain to you guys, there's another way of doing this instead of looking at this matrix. The other way of doing it is by taking like these numbers. So this is row 1, column 1, right? This is row 1, column 2. This is row 1, column 3. What is 1 plus 1? It's 2. So this would be raised to the 2 power, and it's always going to be a -1. So it's always -1 raised to the 2 power. So for row 1, column 1. And what is -1 raised to the 2 power? It's +1, right? Okay. What is 2 and 1 and 2 equal? It's raised to the 3rd power. So -1 raised to the 3rd power, what is that going to be? So if you know the row and the column, you just add those together, and that'll tell you if it's going to be positive or negative. So let's make this one a -1. What would I raise it to? What power would I raise that one to? Yeah, that would be raised to 4 because 1 plus 3 is 4. -1 raised to an even power is going to be positive. And so that's another way of finding out like what sign you're going to multiply it by to find your cofactor. Finally, let's find our determinant. To find our determinant, we're going to go 0, and we're going to multiply that by that cofactor, 2 times that cofactor, plus 1 times that cofactor. That's going to give us our determinant. Our cofactor for our row 1, column 1 is going to be -1. This one's going to be 5, and this one's going to be 4. Now you can see we didn't really need to do all of this work right here because we just ended up multiplying it times 0. So in the future, know that. So this is going to be 10, and this is going to be 4. Our determinant is 14. Done. Come on, guys. That is crazy. You can take any row, any column, and you'll get 14. Come on. That's not cool? You all suck!
We know.
You know what's cool? If there's actual lasers killing those.
That would be cool. Actual lasers would be awesome. No, you can't kill your math books.